Okay. Yeah, so I guess it goes without saying this type involves profit or revenue. They mean the same thing. We're going to have to generate a table that looks like this. It's important that you have profit at the end, but cost and items, it doesn't really matter which one you do first. And I think I need you to just understand that, right? If you sell, like, let's say something is costs $1.50, right? And you sell 10 of those, right? Then it stands to reason that it would just be 150 times 10, which is $15, right? Your profit. And watch this. If I knew, for example, if I knew that my profit was 15 and that I sold 10 of them, is there a way to possibly get to this answer? Right? If you go 15 divided by 10, it would get you that, right? Same thing if I don't know the number of items, but if you do know both of these, right, you can figure out how many items there are just by going 15 divided by $1.50, you get 10 items, right? So they're related. Everything is related. So if you know any two, you can find the third missing component. Okay, that's going to be handy later on. Then we talked about our graph. What the two different, that table that I just told you is able to generate two different equations, right? You can compare cost and the profit, or you can talk about the items sold and the profit. They both result in a parabola, but to be honest, this is a little deceiving. It's not going to look the same. One parabola is going to be a little steeper than the other, right? But they still, one thing is certain, I can guarantee you that this max profit will be the same as the max profit. Like that maximum revenue that you can attain will be the same regardless of which parabola you're considering. Okay? It's just that the X values will differ. Because this one talks about how many items you sold. This one talks about how much, what the cost was per item. Right? So keep that in mind as you go through this. So let's flip over and do our first example here. Okay. You just get all set up here. The movie theater charges $1.80 per ticket. At this price, it sells approximately 400 tickets per day. The theater manager has observed that for every 10-cent increase in price, there are 40 fewer tickets sold. And that should make sense to you, right? Like if you increase the price, there's a chance that you're going to sell less, right? And so let's just highlight the important pieces here. $1.80 per ticket. This is how much you're selling. And if there's a 10-cent increase, there's a 40 decrease or 40 tickets fewer from the 400 that you started off with. Okay. So if you make your table, you need at least 3 points, right? That's where the 3 rows come in. So the top are just your titles. The most important one you need to get right is that this is your profit. Okay. And then the other 2 you decide. So we can go cost per ticket. And this is going to be the number of tickets. And that's why I call this type 1, because then you know how to set it up. It could be anything. In this case, we're talking tickets, right? So it's $1.80. Fill that in. We know that at the beginning they basically give you a point, guys. $1.80, and under that price, you're selling on average 400 tickets. So to get the profit, we would just go $1.80 times 400. Just leave it like that for now. I'll tell you why in a bit. And now we need to decide, okay, the price, if the price goes down by 10 cents, and this is my price, right? So I'm gonna, from here to here, something happens. I go minus 10 cents, right? Minus 10 cents. So this would be $1.70, right? I use nice round numbers, so it makes it easier to explain this. Yeah. Oh, increased. Yeah. Good catch. Good catch. Yeah, sorry, there's a 10-cent increase. If you increase the price, what happens to the tickets every time that happens? You drop by 40, right? This drops by 40, so you're down to 360 now. So if the price goes up, your number of tickets sold goes down. So this would be $1.90 times 360. And then that goes one more time. You could do more, but we're going to always just stop at 3 because that's all we need, right? So this is plus 10 cents. So that gets you to $2 a ticket. And watch this, you need to subtract 40 again. Okay, so that's 320 tickets, which under those circumstances, you take the $2, you multiply that by 320, just like that. You have 3 columns, right? Which one gets L2 every time? This one will get L2, so you can go ahead and just write L2 into that. Those are my Y values. What about which one will get L1? So we first read. Determine the equation relating the ticket price and the profit. So that tells you that this goes into L1. And of course, we already know that profit goes into L2. So the ticket price is this first column. So we're going to go arrow and then L1, and that's going to be representing our X values. Okay, so let's go ahead and perform the regression. So stat calc 5. Oh, actually, first we enter this, right? Otherwise, it won't work. So 180, 190, and 2. And now you just observe what I'm about to do here. For L2, I'm actually going to go 180, sorry, $1.80, so 1.8 times the 400, right? Times 400. Just type that into that cell, right? I'm actually typing in 1.8 times 400, and then I'm going to go 1.9 times 360 and 2 times 320. And why am I doing this? Because I see a lot of students multiplying this and then they somehow get it wrong here and then they copy that into here. And even if you're off by 1 or like you miss a 0, it throws everything off. So once you have done this, then you can actually write it in if you'd like. Right? You just copy what's in the cells. But warning, the cells round. So you got to watch out for that. Those cells will round to 1 decimal, even though it might be a 2 decimal answer. Just got to watch out for it. So this is optional. I don't need these numbers there. What I do need is, just tell me that you're multiplying 2 numbers every time. Now you go ahead and perform your regression. Before I do so, I'm going to turn on plot 1, correct? You don't have to clear what's in Y1, but I am going to clear it. But now you perform your regression. Stat 5, right? Stat calc 5, 1, 2, comma. Remember, between entries, you need to put commas. And there it is. And make sure, should I I will write this down and I'll show you what happens when you get this wrong. So this is your equation. Notice that sometimes C will be a really small number. It will have like a e to the -8. That's 0 for us. Okay, so don't write that down if that ever happens here. So don't do this, but I will just show you. So let's say you had just written down, you went L1, L2, right? L1, L2. And then if I run that regression again, what do you notice? What's my A value like? 0. So that can't be, right? In fact, if you try to graph that, if I go zoom 9, it's going to be it is actually going to be a straight line. Okay. So I don't want that. So I'm going to fix that quickly. Right? And I'm just going to type in actually the values. Do that one more time. There we go. That's better, right? A is not equal to 0. You want to write that down. Note, right? A cannot be 0. Okay. If it is, remember today's lesson, right? Let's go zoom 9. This is where zoom 9 is not going to be your friend. Zoom 9 is, you'd be like, oh, I made a mistake, right? It looks like linear. I must have made a mistake. No, you know what it is? Is these points that we found, they're very close together. Very close together. So they're only showing you like a little stretch of this. But it's actually an easy fix, okay? You go to your window and remember, I need to see my y-axis. So I'm going to go -5 there. And the y-min, I'm going to go -10. Why -10? Why not? Because there's a bigger number there. So I'm just going to go a little lower. And then you hit graph. And it's going to be better. Not quite fixed yet, right? So I have to adjust my y max and my x max still. Not by much. You can tell that don't go hundreds here, right? We're going to go x max, I don't know, 10. It might be too much. And y max, I'm going to go maybe 1,000. And that's pretty good in my books. That's a decent graph. It's manageable. You can see it. And you can see those 3 points that we were zoomed into earlier, right? That's what it looked like, a straight line. So don't be alarmed when that happens. So this is not a good zoom 9 example. Okay, but anyways, it gets you started at least, right? It's good to see something and then you adjust accordingly. So we found the equation. What ticket price would result in the maximum profit? What is the maximum profit? So what is it? If you notice, right, the maximum profit is found at the vertex. Okay, found. It's not the vertex. It's found at the vertex. Okay, that's where you can get that information. So let's go ahead and find that. Second, oh, another mistake that I see. Second trace max, right? So well, I'll just write max instead of 4. That way you know. If your parabola is pointing up, like there's something you got to go back and check. Maybe you were subtracting instead of adding. Maybe you mixed up. You actually went down by 40 here and up by 0.10 here. I don't know. Like something is seriously wrong there. The profit type question will always go like that, most likely. Okay. Anyway, so let's go ahead and find it. Second trace. So there it is. I'm going to go 140, 784. Do not kind of guess based on these points here, up here on your table. Oh, I think it's about between these two. It has to be an exact value using your calculator, okay? So max profit max profit is $784. Okay. The ticket price, right? Ticket price is $1.40. So if you charge $1.40, you will actually get that maximum profit of $784. I found the vertex and then I answered both at the same time. Could be that it only asks for the max profit, but in this case it asks for the ticket price at that point and the max profit. Let's I actually added this for a reason here, this little graph. So let's just go, and this would be in my case, based on this is ticket price, right? We can just go price in dollars, that would be your unit, and this is your profit in units, which is dollars and dollars, right? Both of them are in dollars in this case. Do we know this point here? It's actually 0, 0, right? Because my y-intercept is 0, 0. So 0, 0 is part of this. This is 140, 784. And I don't know this point just yet. Am I going to ask you that? I don't think I'm asking. So we'll leave it for now. I might insert that somewhere. Don't do that. Anyways, keep going. How many tickets are expected to be sold at the price in C? How many tickets would you expect to sell up there? Well, recall that tickets times the cost is equal to profit, correct? What do we know of this equation here? What do we know? We know that the profit is 784. The cost is $1.40. And the tickets would be kind of like our unknown, right? So what would you do there to figure out the number of tickets? You want to get rid of that, right? So you would just divide both sides by $1.40. Because that allows you to do that. If you just remember, right? If you have your profit in either tickets or cost per ticket, you can just divide and get, in this case it's a round number. It will not always be a round number. It's 560, right? I will add that here, round to whole number if necessary. What ticket price or ticket prices would give or yield in the financial industry? Yield is like how much are you going to earn? Like how much is this going to give you? Right? A profit of 450. This is the Y value, right? Y value given, right? Therefore, we're going to let Y2 equal to 450 and figure out what the ticket prices would be at that point. So grab your calculator, go to Y equals, let the Y2 equal to 450, and then let's graph it. And you can tell that there are two instances where that happens. Why is that, right? Well, let's first write it down, then we'll worry about the explanation. So I'd like a sketch here. This is the 450 line, right? So there's a ticket price here, and there's a ticket price there. Okay. Remember, the price is along the x-axis. So we're going to find both of those instances. Let's go ahead and find a second trace 5. Doesn't matter which you find first. I'm going to find that one. So this would have a 2.31 ticket price. And if we jump and cross the street, you have 0.49 if you round that. I'm just going to go back here and go y2 is equal to 450, and then I'm going to go second trace 5 just to complete that. The steps required, right? Okay. A profit of $450 will be achieved at ticket prices of 49 cents or 231. And the reasoning is, what's happening in the background is if you sell it for cheaper, you're probably going to sell more. You're going to sell more tickets, right? And get to 450. If you sell it at a higher price, right, you're going to sell fewer tickets, but it's still going to overall get you the same results, right? So as a company, you have to decide what is more important to you. Do you rather have it more accessible to people, right? Which you're still going to make the same amount of money, right? But you're going to make it more accessible, or do you want it? Are you limited as in how much you can offer, but you'd still like to make 450, so I'll charge a little bit more, right? But still are achieving the same end result. So I'm going to just write this down here. I'm going to say lower ticket price, right, will result in more sales, right? Higher ticket price, fewer sales. But they both give the same end result. Same profit. Both give the same profit. This is kind of like a box here, perhaps, right? That's the explanation as to what's happening there. And graphing. You need to be able to graph these. We already know quite a bit, but not everything. We don't know the x-intercept. I don't know if you've caught that. We call it the break-even point. So I'm going to wait a little bit. If you want to go ahead and already set your calculator so that we can find that, I'm going to go ahead and find the x-intercept with you. So let y2 equal to 0. I'm going to go up to my graph. I'm just going to do a little inventory. The vertex is 140, 784. The y-intercept is 0, 0. X-intercept is therefore 0, 0 as well. 0, 0, right? They're both the same. But the second x-intercept, so let's go comma here. Let's find the other x-intercept. So even though I didn't ask you for it, it's required for the graphing part. So that's 2.80. You could have predicted this, couldn't you? The 280? If you think about it, because I want you to see that everything is connected, right? I keep on saying that because that's so important. If you have a understanding, remember axis of symmetry? If from 0 to here is 140, then another 140 will get you, right? Because these are right across each other here. This should be, let's put this down here, 280, 0, right? Shouldn't be a surprise. Especially the case because they're opposite each other, right? So when we have 2 points that are on either side of the legs, we can kind of figure out what either the vertex is or the third point in this case, that'd be our third point. Okay. So we have our inventory here. Let's graph it. So I'm going to make sure I don't lose any marks for this. So this is, in my case, is price per ticket in dollars. There you have profit at the top, also in dollars. I'm looking 280, right? I need to fit 280 in here. So 0.51, 1.52, 2.53. So that works. And I'm just going to make sure I indicate clearly that my markings go here, right? So that grid is supposed to help you, but you still need to fill it in, right? And obviously, I think it goes without saying that this represents 0, right? You don't see me put the 0 down very often, but it's implied here. Same with the y-axis, right? Starts at 0 and then, so we need to make sure we have enough for 784. So 800 or so. So 200, 400, 600, 800, that works pretty good. So I'm going up by 200 here. And then so 140 is right about here. I'm going to go up that to 784, which is right about there. 240 is right about, sorry, it's 280, right? Sorry. In the middle will be 275, so a little over. And then just go like this and go like this. Don't forget your equation. And there you have it. Everything is the way it's supposed to. And we can then state our domain and range. My domain is the acceptable x values for this graph. Notice we're not going into the negatives. You could, right? Technically, you could go into a deficit, right? You could be losing money. I would have to be very clear with that in the question. I would indicate like what price would you end up losing money, right? Or what would be the profit if you sold it for like $4, right? If you went to $4, you'd probably be somewhere down here, right? So I would indicate that you'd probably be losing money there. So domain is 0 to 280, and the range goes from 0 all the way to 784. There you have it. Okay, So now this is not going to be very often the case, but I decided, that you notice that my problems have a lot of questions, right? Because I kind of want to cover all possible scenarios. Go ahead. So what if it says this? Determine the equation relating the number of tickets and the profit. So now tickets goes into L1, profit goes into L2. What's going on there? Go to stat, edit, question. Do we need to change these entries here? No. All you need to do is go to L1 and start typing in your ticket number, like how many tickets are sold, right? And we need to run another regression now because this is a different graph. So if you have the regression on your screen somewhere, right, just copy it. Oh, don't have answer on there. That's wrong. Sorry, I kind of got it wrong now. So that's my resulting equation. Negative 0. I'm going to use all the decimals because it's just there, right? Plus 2.8x. And remember, you're now depicting the number of tickets sold. So yes, it will be a different parabola. Let's go over to this graph here. And here you have tickets, and we'll say number of. Those are our units. And we still have profit here. That still stays the same. Let's find out the maximum profit. What do you think it's going to be? You can already tell that it's going to be 784, right? I just want you to see it for sure, right? So second, trace 5, but the x value will not be the same. Let's try zoom 9. Oh boy, right? You go window, -5 there. Y min, I'm going to go -10. Try it again. That's better, but I need to extend my Y max and X max now. Maybe you're going to start doing that automatically. Sure, if you feel like you've got this, if you don't want to, oh, I need to increase my X max still a little bit. Let's go 1500 for X max. There we go, that works pretty good. Let's find the vertex now. Max. Oh, and I got it wrong, right? My keystrokes. 4, right? This is just max. Let me just find the vertex first. And that's 560, 784. Do you recall seeing 560 at some point? Previous page, remember? D on the previous page. We figured out that we would sell 560 tickets at that. So this is supposed to say max here. Okay. Yeah, it's not 5, it's 4, right? So max to avoid any, right? So max profit is still 784. Okay. Tickets sold is 560 tickets. Same as D, right? Can't see that, can you? There. Same as D. So let's write this here. It's important for you to know that this is 560, 784, because now we're comparing the number of tickets to the profit. What do you think the x-intercept is without a calculator? What's 2 times 560? 1120. But hey, we want to make sure, right, that we're not getting this wrong. So I'm going to go to it, enter, enter, enter. Oh, it's 1120, right? So you can use your calculator, you can just use axis of symmetry. Just be careful that you do it right. This is called the break-even point, right? This right here, remember that? That's break-even. Let's maybe make an arrow. Break even. So you would break even if selling 560 tickets, or you would break even at 0. But that doesn't make, right? That obviously if you sell 0, you're not going to make any money, right? So that goes without saying. All right. You know what? This is type 1. Are there some curveballs? Yes. You got to watch out. Let me see what's on the back side of this. That's already type 2, fencing. So this is it for type 1. Just one big example because they're all fairly the same. So I'm going to give you class time today to work. How's that? Page 12 to 17 in the workbook. Lots of questions. One page per question, most likely. But I want you to take that book out, and I just want to clarify a few things. Because I usually mix it up. I don't just do type 1, type 1, type 1. You might have some type 0s. Type 0s in there, some type 1. So if we go to 12, 12 is a regression, that's a type 0, right? And it used to be an AC, it might still be an AC, who knows? But that, you can do that. Type 2, or sorry, question 2 is obviously a revenue type question. And they're actually all, okay, type 1. All right. Except for page 17. Does it go all the way to 17? Yeah. 17 is just, here's the equation. Do you still remember how to do that? Right? Do I expect you to do them all? I don't think so. Obviously, that'd be great. That'd be awesome. But I think that would take a long time. So I would say you should try at least 2 type 1s. Right? Those are now the ones you just learned about it. And then you pick, do you want to do a type 0 or do you want to do one with the equation only? Because that's still going to happen, guys. It's not all going to be regression, okay? So you start maybe on page 13, because that's what we just did. And then you decide what else you need to do. I'm going to look for the key and post it shortly. And that's it for today. But make sure you start, because if you start, you're more likely to actually continue, right? The research shows that. So get started in your workbooks. And if you don't have a workbook, you can borrow one. You don't have one? Okay.